Finding the domain of a composite function. If f of g of x equals f of g of x, the function g is referred to as the input function, because that is what we'll be inputting into f. And the function f is referred to as the output function. In determining the domain for the composite function, the domain of the input function and the domain for the end composite function must be accounted for. So what we mean by this is when you find the domain of a composite function, you need to make sure that we take into account the domain of the input function and the domain of our end function once we've composed them together. So let's look at an example of this. Find g of f of x if f of x equals 5 over x plus 4 and g of x equals 3x over 2x minus 1, and state the domain of g of f. Okay, so if we're trying to find, so let's first figure out what g of f of x is. All right, so that's going to be taking g and inputting in f of x, which is 5 over x plus 4. So we'll go to our g function. Anywhere I see an x, I'm replacing it with 5 over x plus 4. Okay, now this looks pretty ugly. This comes from complex fractions that you learned about in previous math classes, in Math 95 specifically. If you need more on simplifying complex fractions, please feel free to shoot me an email and I can easily get you some great links that'll review this concept, but I'm also going to review it here. So it's called a complex fraction because we have a fraction within a fraction. So when we can't leave it like that. So there's two different methods that you can use for simplifying this. There's one that I usually predominantly use, so that's the one I'm going to use here. What I usually do is I figure out what is the common denominator of both of my complex fractions. And in this case, that common denominator is going to be x plus 4. So what we can do is multiply the numerator and denominator by that x plus 4. When we do that, we're essentially multiplying by 1 because x plus 4 over x plus 4 is just 1. Okay. So when I do that, I get 3 times 5 over x plus 4 times x plus 4 all over 2 times 5 over x plus 4 times x plus 4 minus 1 times x plus 4. That's because I have to multiply the entire denominator by that. Now the reason I chose the x plus 4 is because these will cancel out with the numerator and denominator. So that leaves me on the numerator with just 3 times 5, which is 15. And in the denominator with 2 times 5, which is 10. And then minus x minus 4, which reduces to 15, or simplifies to 15 over 6 minus x. So I've just taken something that looks pretty ugly and I've simplified it to a much simpler version. Again, please feel free to send me an email and I can give you some other great links to complex fractions if you need a little more help on this. Now, for stating the domain. Okay, so we need to take into account the domain of the input function. So our input function was f of x. So the domain of that is x cannot equal negative 4. And then the domain of our end composite function, so for this one, x cannot equal 6 because again, the domain are all the values that you can get output values. So here, our input value of 6 would give a denominator of 0, which we cannot have. So the domain of the composed function so now what we do is we combine these together. So the total domain of g of f is x such that x cannot equal -4 and 6. So again, when you're coming up with the domain of a composite function, you take into account the domain of the input function and the domain of your end function. Let's do another example. Find f of g of x if f of x equals 5 over x plus 4 and g of x equals 3x over 2x minus 1. State the domain of f of g of x. So this is basically the same thing, except now I have f composed with g instead of g composed with f. So g of x is 3x over 2x minus 1. That means I go into my f function, and anywhere I see an x, I'll be replacing it with this, which gives me 5 over 3x over 2x minus 1 plus 4. Again, I'm left with a complex fraction, so I'm going to multiply the numerator and denominator by the least common denominator. So multiply both the numerator and denominator by 2x minus 1, which is the same thing as multiplying by 1. It's just an ugly one. So the numerator becomes 5 times 2x minus 1. With the denominator, we get 3x over 2x minus 1 times 2x minus 1 plus 4 times 2x minus 1, because again we have to multiply the entire denominator by that. When I simplify, this leaves me with 10x minus 5 on the top. Those cancel, so I'm left with 3x plus 8x minus 4 in the denominator, which gives me 10x minus 5 over 11x minus 4. Okay, so for finding the domain of both of these, we need to take into account my input function and our end function. So the domain of the input function is going to be the values that would make this denominator equal 0. 2x minus 1 equals 0 when x is 1/2. So the domain of the input is all values of x such that x cannot equal 1/2. And then the domain of the end function is all values of x that would make this denominator equal to 0. So 11x minus 4 equals 0 when x equals 4 over 11. So I need to also exclude that value. So this means that the domain of my composite function, when I combine these, all values of x such that x cannot equal 1/2 or 4/11.